Now we're going to start talking about polynomial functions and their real zeros. So objectives, we're going to understand the factor theorem, and we're going to factor higher degree polynomials completely. And we're going to analyze polynomials having multiple zeros. We're going to be able to solve higher degree polynomial equations and understand the intermediate value theorem. All right, so factor theorem. A polynomial has a factor of x minus k if and only if f of k is equal to 0. So we just need to remember here that f of k, technically another name for y, is equal to 0. And if y is equal to 0, it'd be nice for us to remember graphically that right here, the graph of f, which is whatever function we're looking at, is going to be an x-intercept of k comma 0. So here's what we need to know. So this is going to be minus k. And again, notice the opposite, f of k. Here it's positive. And whatever the k value is going to be our x value. And our 0, this 0 right here, is that our y value is 0, which means that our y value is 0 on a coordinate, on an ordinate pair. Another thing that it means, number 2, a real 0 of f is k. That means that f of k is 0, and again a 0 is the x value of the intercept. And so it's technically what I just said a couple of seconds ago, but here not just written out flat out. And here a factor of f is x minus k. So the whole thing about it, the fact that it's a factor, is that technically we're going to be putting it in parentheses here. So I'm going to stress those. And the factors are going to be multiplying each other out. So you'll see. Look at this example. It says, use a graph and the factor theorem to list the factors of f of x. Assume that all the zeros are integers. So integers are positive and negative whole numbers, including 0. So let's see. Here on this one, so this point right here that I'm outlining is negative 2, 0. So for negative 2, 0, then our factor is going to be parentheses and then x and the opposite of the minus 2. So the opposite of minus 2 is going to be plus 2. So let me highlight it here, and maybe it shouldn't have been in green, but this minus 2, maybe I'll just underline it, is the opposite right there. Okay, next one. I'm going to have this one right here. This is negative 1 comma 0. So for negative 1 comma 0, then our factor is going to be equal to parentheses x plus 1. And again, it's going to be the opposite for our x values. So this minus 1 becomes this plus 1. Our next one. We have this x-intercept right here, which is 1 comma 0. So for 1 comma 0, sorry for the background noise, the factor is parentheses x minus 1. Again, it's repetitive, but it's brand new to most of us. It's going to be the opposite. And then our last one, this right here, this x-intercept is going to be 2 comma 0. So for 2 comma 0, then our factor is going to be parentheses x minus 2. Now, so hopefully so far so good. The next one, example, use the given zeros to write the complete factored form of f of x. So we have f of x is equal to 6x squared plus 21x minus 90. And they gave us that the zeros are negative 6 and 5 over 2. Okay, so let me write this down. So here's what's happening. Let me change colors here. So I have f of x, and this 2 right here, hang tight. I'm going to do it. Shucks, sorry. This 2 right here, come on, technically tells me that I have two zeros here. And in this lesson, they're going to all be real. They're actually going to be actual x-intercepts on the graph. Later on, we're going to have some imaginary answers. So this 2 technically tells me that I'm going to have 2 sets of parentheses. Shucks, 1, 2, being multiplied. This right here, the zeros are -6. So the opposite of a -6 is going to be +6. And then we write our x. And I'm going to start switching colors here. Dang it, it's too dark. So this 5/2, the opposite of 5/2 is going to be right here, minus 5/2. So I have x plus 6 parentheses times parentheses x minus 5/2. So the next thing that we're going to do is we're going to check by distributing. So what are we going to check? Well, we have this, we're saying that f of x is the same thing as this f of x. So we're going to distribute these two parentheses to see if we get the answer that we have right here, this 6x squared plus 21x minus 90. All right, so let's change colors here and let's see if that happens. So x times x is going to be x squared. And then I'm going to have x times minus 5/2 is minus 5/2 x. Then I'm going to have 6 times x, which is plus 6x. And then I'm going to have 6 times 5 times a minus 5/2. So a plus times a minus, I take care of my signs first. So a plus times a minus is going to be a minus. 6 times 5 divided by 2. I can do the 6 divided by 2 first, which is 3, times the 5 is 15. So I get x squared minus 5/2 plus 6x minus 15. And again, so far, this is what I have as my f of x. So far. So it doesn't look good because I have a 6 in the front as my leading coefficient, and so there's going to be some modifications that we need to do. But first, let's move this right here needs to be combined. So going back to our fraction days in 5th and 6th grade middle school type thing, minus 5/2 x's plus 6 x's. Well, they're going to combine, and you can use your calculator or the noodles that God gave you. But here it's going to be plus 7/2 x. Technically, it's because the 6 is over and understood 1. So the denominator is going to have to be a 2. So I need to multiply the 6 times the 2, which is 12. Minus the 5 gives me the 7 that I just got there. I've not used your calculator. And this is going to be minus 15. So right now, it doesn't look the same. It does not look the same as this one. So we're a little sad here. But we can see if that I multiply everything by 6, I'm going to get the answer. So if we don't see that, that's okay. Here we go. So I'm going to write here, we're missing 6 as a factor. So therefore, this is going to be technically, this is 6, parentheses x squared plus 7/2 x minus 15. And now let's check it. Again, by distributing. So let's see, 6 times x squared is going to give me the 6x squared. The 6 times plus 7/2 x, so 6 divided by 2 is 3, times 7 is 21, or again, check with your calculator, so 21x. And then I'm going to have 6 times minus 15, which is going to give me minus 90. And so now, all of a sudden, we are happy. And why is it that we're happy? Again, because we ended up getting our original expression. So now that we have the original expression, then we can say with confidence that our answer is going to be f of x is equal to, we have the 6, parentheses, and then x plus 6 times the x minus 5/2. That's the fully factored form. All right, next one. So it says, example, use the graph to factor f of x, assume that all zeros are integers. So f of x is equal to negative 2x cubed plus 2x. Okay, so then this one says, we have a cubic. So again, for right now, for this lesson, that means that we're going to have 3x intercepts. In future lessons, we're going to have imaginary ones. So we're starting off easy. So we have 3x intercepts. Yeah, we sure do. 1, 2, and 3. Those are our 3x intercepts. All right. But we're going to identify them one by one. So this point right here is going to be negative 1, 0. So for negative 1, 0, our factor, I'm going to put it right here, is x plus 1. For the next point we have right here, it's going to be 0, 0. And so for 0, 0, I'm going to be teacher, but technically it's x plus 0 or minus 0. Doesn't really matter. But really x plus 0 is technically just x. And so I'm going to highlight just to make sure that you know that I know that you know that I know that you know. This minus 1 is the one that is the opposite of that. And this 0 is the opposite of that one. But 0 is kind of special case. Okay, next one. This one right here, this point is 1, 0. So for 1, 0, the factor is going to be x minus 1. And again, this is 1, so the opposite in factored for the factor form is going to be minus 1. So far this is what we have. So let's check. I was going to say I didn't make that error, but I do it in every lesson. Okay, so let's check. So right now we have f of x is equal to parentheses x plus 1, technically times x minus 1. And so we need to distribute. So I'm going to distribute, technically I'm going to just work with, let me underline here. I'm just going to work with these two first. So I'm going to do x times x, which is going to give me x squared. And then I'm going to do 1 times x, which is just going to give me plus an x. So I've distributed now. So now this new one, I'm going to now work with this one right here. So here we go. X squared times x is going to give me x cubed. X squared times a minus 1 is minus x squared. X times x is plus x squared. And then x minus an x minus a 1 is minus an x. And so simplifying it out, I get x cubed, the x squared's simplified to 0, and I get minus an x. So looking at the original picture, not picture, but equation, I'm a little sad because we didn't get the exact same thing, but hopefully after looking at it after a while, we're going to say we're missing. If you want, you can pause it and and guess yourself. We're missing negative 2 as a factor. So we're going to have equal to, so we're going to do negative 2 and x cubed minus an x. And if we distribute, we're going to get negative 2x cubed plus 2x, and then we're happy. Because this right here is that right there. So now what's our final answer? Our final answer is that f of x in fully factored form is going to be the negative 2 times the x squared times, x plus 1 times x minus 1. Here's our answer. We're going to talk about multiplicity. So multiplicity is the number of times a factor appears in the factored form of a function. Very important, especially if math is in your future. Even multiplicities touch the x-axis. Odd multiplicities are going to cross the x-axis. So let's look at this one here. So I have f of x is equal to x plus 1. So if you notice, this is technically, let me write this down. This is technically, we have parentheses, and it's to the power of an understood 1. So our x-intercept, let me hang tight here. So this one right here, since our 1 is odd, therefore the graph is gonna cross, or graph crosses, the x-axis at x equal to -1. So why the -1? Because it's always going to be the opposite of this one. Always. And there is our x-intercept right there of -1. So crossing means that it goes from one quadrant to the other. It literally crosses the x-axis. And let's look at the next one. So this right here, our power is a 2. And again, you're looking at the power on the outside of the parentheses. Who cares about the power inside? It's always the one on the outside, assuming that you factored it completely. You did this process like what we did in this previous problem. You did it correct. You're only looking at the power on the outside of the parentheses. Okay, so for this one, the 2 is even. Therefore, the graph touches the x-axis at x equal to -1. So here's my x-intercept, and it only touches it. It touches it and it turns around. It does not cross it. So again, here we go. And then this last one, I don't know what happened with all of my margin here. So again, hopefully we're able to see a pattern. So this power on the outside is a 3. So the 3 is odd. Therefore, the graph crosses the x-axis at x equal to -1. So right there, again, it crosses, it doesn't turn around, it just literally crosses it. So it bears repetition. This power, this 4 is even. Therefore, the graph touches the x-axis at x equal to -1. And like we saw on the previous lessons, technically, without any other transformations, it just gets flatter. It looks like a parabola, but right at the turning point, it gets flatter and flatter. And so last one here, this 5. So again, that highest power on the outside is a 5. It is odd. Therefore, the graph is going to cross the x-axis at x equal to -1. And again, that -1 is that -1. And again, they're always going to be the opposite of the factor. Okay. Example. It says estimate the integer zeros and state whether their multiplicities are odd or even, and state the minimum degree of f of x. So we have this funky looking graph. Both of the arrows are headed down. So that should trigger in our head that it should be even. Our final answer better be even. Because that's how the end behavior for even graphs look. Now, it's obviously not a power of 2 because it has too many turning points. So it's not a squared. Could it be a 4? The turning points are technically, it could have 3 turning points. So this one has 1, 2, right here and right here. So it could be a degree of 4, but maybe not. But let's take a look, or 6, or 8, or 10. But let's see. So let me undo this here. So let's do it step by step here. So let's estimate the integer zeros. Okay, so right here for this one, so let's just do this as part A. So for part A, and let's start. So this one right here is gonna be, so my x-axis is going by 2. So this is gonna be -8. So this is gonna be -8, 0. And if you notice, it touches the x-axis. It does not cross. So it's gonna touch the x-axis. So my 3 little dots is therefore the multiplicity is even. And my factor has to be the opposite of this one. So it's going to be parentheses x plus 8. And since the multiplicity is even and the factor is x plus 8, then the minimum, the factor is going to be technically the minimum factor. I should say the minimum degree, excuse me, is going to be 2. That's the lowest it could be. All right, so for the next coordinate, so taking this really slow, this one right here. This one is going to be -4, 0, and it crosses the x-axis. So therefore, the multiplicity is odd. Because it curves, so that's because, BCZ, sound it out, because, you don't even need the U for those of you that texted. But anyway, because it curves, the minimum degree, so min is for minimum degree is equal to 3. Okay, so some of you are like, whoa, why not 1? Okay, so let me look up here. Look at this one. When the degree is 1, it literally goes straight through. No curvature at the x-axis. And starting at degree of 3, we have that curving feature. And so since we're looking for the minimum degree, it's going to be 3. Even though 5 also has that curvature. But since it's asking for the minimum degree, the lowest number where it actually starts curving is going to be 3. Okay, so the last x-intercept that we need to look at is this one right here. So this is going to be 2, 0. And if we notice, it crosses as well. So it's going to cross, it crosses the x-axis. Therefore, multiplicity is odd, and this one too curves. Because it curves, the minimum degree must be 3. Okay, so now taking all of these minimum degrees that we just found, which is the 2, the 3, and the 3, we're going to add them up. So 2 plus the 3 plus the 3 is going to give us that our minimum degree is 8 of the entire function. Sorry for the background noise if you hear that. So I'm doing a lot of examples. I know this is a longer than usual section, but it's brand new. So I'm doing a lot of examples and I'm going really slow. So if you want to fast forward me, that's a-okay. So example, it says write a polynomial f of x in complete factored form that satisfies the conditions. Let the leading coefficient be a 1. So it says that the degree is 5. The zeros are -2 with multiplicity of 2 and 4 with a multiplicity of 3. Okay, so let's break this up. So we're going to have a f of x. Our leading coefficient is going to be a 1. So we really don't have to write it down, but I'm still going to write it down. So this is a 1, which is that one. And let's see. So for this first one, so we have one of the zeros is a -2 with a multiplicity of 2. Okay, so then that means that my factor is going to be x plus 2. And where did I get the plus 2? I probably shouldn't have used green, but this -2 right here is this plus 2 right there. And a multiplicity of 2, this 2 right here, that's not what I wanted to do. It's too dark. No, it's right. This 2 is going to be that 2 right there. And then the next thing that they told us is that the other 0 is 4 with a multiplicity of 3. Okay. So it's going to be x, and it's going to be the opposite of 4, so -4, and a multiplicity of 3. And so all of my factoring here, I've been doing this -4 is this 4, and then be nice to me. I'm having too much fun with my color, sorry. This 3 is that 3 right there. And if I add up the degrees, the 2 plus the 3 is in fact the 5. Now, I'm not going to check it. They didn't give us an original function to check, but to check it, we would have a lot of multiplying to do. We would have to do the x x plus 2 times the x plus 2, and then FOIL it out. And then the x times x minus 4, 3 times. Okay, next one. Given the graph, write the complete factored form of f of x. Okay, so we always start off with the zeros here, which are our x-intercepts. And so this one is -1, 0. So for -1, 0, it touches the x-axis. Therefore, the multiplicity is even. Therefore, the minimum degree is equal to 2. The factor is gonna be x, plus 1. And again, where did I get the plus 1? It's the opposite of this value right here. And the minimum degree is a 2. So here on this one, I'm going to start writing up my equation here. So I have f of x is equal to, I have an x plus 1, minimum degree of 2. Okay, the next one. taking this really slow. And if it's again too slow, fast forward me. So here on this one's going to be 1, 0. And this one crosses the x-axis. So it's going to cross the x-axis. Therefore, the multiplicity is odd, excuse me, sorry. Therefore, the minimum degree is equal to 3. And the factor is going to be, should be equal to, x minus 1. And so using everything that we've learned about this one, this is going to be times parentheses x minus 1, and the minimum degree is a 3. All right. So I haven't used the graphing utility here, so I'm going to use it now. I've said that you can use the graphing utility to check your work, but I haven't actually checked it. So now I am. I'm going to do it graphically. So this is going to be x plus 1 squared, and then times parentheses x minus 1 to the power of 3. And so I'm going to make my graph. So my x's go all the way up to 3, somewhere there, and then they're zooming in here. Okay, I'm spending way too much time, but just so that we get the idea. So let's see our x-intercepts. So yeah, our x-intercepts are negative 1, 0, and positive 1, 0. That's good. But here on our coordinate grid, so hang tight. Sorry. This point right here looks to be like 0, what is it? Maybe 0, 2-ish, maybe? Negative 2-ish, sorry. 0, negative 2-ish. And right here it's 0, negative 1. So we're not happy. Technically, we're missing a stretch. We're missing a stretch here. Going back to our transformations. So let me write that down. We're missing a vertical stretch by a factor of 2. So this 2, we're going to put it right here. So how do we do a vertical stretch? We multiply it on the outside. So here 2 parentheses x plus 1 squared times x minus 1 cubed. So let's see if I put a 2 here in the front. Okay. And so 0, negative 2 definitely matches. And then these match as well. And then this right here, this turning point, pretty close to the one that's on the graph. So this right here is our answer. Now, how would we have done it algebraically? Well, multiplying it all out. Multiplying this all the way out, and then multiplying it with this, and then we would have seen that we were missing a factor of 2 on all of our leading coefficients, and then we would have put this 2 right here. Definitely time consuming and not enough space here. All right, next example. It says solve for all real solutions numerically, graphically, and algebraically. So let me fill in the blank here for the remember. So this remember is very important. Remember, numerically, we are looking for when the y value of the function is equal to 0. Graphically, we are looking to see when the function crosses or touches the x-axis. And this is aka the x-intercepts. Algebraically, we want to find all the x values that satisfy the equation. The key again here is that we are in factoring mode. And once you get a quadratic function or equation, solve that portion however you wish, which is a quadratic formula. Always works. Completing the square always works. Or factoring, which sometimes works. And finally, set each factor equal to 0. All right, so here on this one, technically, numerically, and graphically are about the same thing. So I'm going to do it graphically here. So graphically, again, we can use decimals. So here on this one, let me go to my graphing utility. Let me get this one out. So I have x to the power of 3 plus x squared minus 6x. So I want to make sure I have it. And again, we're dealing with powers of 3. So right now we have 1, 2, 3. They all cross. We could have had just one, actually 2 x-intercepts, but one of them was just touching. So it's possible. So graphically, this is technically what we have. So I'm going to do a quick little sketch. The important part is to label these. So this is going to be negative 3, 0, 0, 0, and 2, 0. So our answers are the x values. So our answers, let me highlight here, are these. So we have x equal to negative 3, 0, and 2 are our answers. Now, numerically, this is what you need to realize. If I were to come here, no, be nice to me, technology. Right here, numerically is just looking at the table. So numerically, we need to realize that for our x and our, technically our y's, we're looking for when the y values are 0. So here we have 1, 0, 0. Okay, how can I go back? Okay. And again, the other one would be, and you can guess and check here, but again, the graph is beautiful. So at negative 3, we also get 0. And here, I guess technically this could be one bad thing about decimals is that it doesn't give you an easy ability to scroll like a graphing calculator does. And the other one would be 2, 0 right there. And again, our answers are the x values. We want to know what are the x values that give us y values of 0. All right. So here on this one, algebraically, so let me do this here. I'm going to see if I can make this fit. So we have x cubed plus x squared plus 6x is equal to 0. And again, I cannot emphasize this enough. We have to be in factoring mode. Factoring mode. Especially since we don't have a quadratic. Once we have a quadratic, then we can use any of those forms that we have listed right here. Okay, so I have x cubed plus x squared plus 6x. The first thing you want to see is like, oh, they all have an x in common. Let's factor it out. So factor out an x. So it's going to be x, and then I'm going to put parentheses. And so x times what gives me x cubed? It's going to be x squared. X times what gives me a plus x squared? It's going to be plus an x. And then x times what gives me plus 6x? It's going to be plus a 6. Excuse me. Oh, some of you are probably like, this is a minus. All right, so this is a minus and that's a minus. This is minus and this is a minus. Sorry about that. And then the thing is that you set each factor equal to 0. So let me write that down. That's what this says here. Finally set each factor equal to 0. So what does that, what does that mean? So this one, you're going to set it equal to 0. X is equal to 0. And this right here, you're going to set it equal to 0. So I should write that down. Set each factor equal to 0. And so this one's going to be x squared plus x minus 6 is equal to 0. Well, this one we already solved it. X is equal to 0. That's it. There's nothing to do. But this one right here, again, it's a quadratic and you're like, hey, I can do quadratic formula or I can factor. So here I'm going to say it's factorable. So we choose to factor. And so this square tells me that I'm going to have 2 sets of parentheses. And then I'm going to have x times x gives me the x squared. And what two numbers give me a minus 6 and add up to an understood 1? The answer is going to be a plus 3 and a minus 2. And then again, you set the factor equal, each factor again equal to 0. So it's going to be x plus 3 equal to 0. This one's going to be x minus 2 equal to 0. So I'm going to put here set each factor equal to 0. And then you solve for x, which is the negative 3. And then here you add 2 to both sides and you get the 2. Woo! That was a lot. And why it's a different color, I'm not sure. But there's your answers. 3 different ways. And technically, again, graphically, numerically, we're using the same tool. So maybe just 2. Next one, last one actually. So objective, solve a polynomial function by factoring using the grouping method. Okay, so I'm going to put a little asterisk right here. And I'm going to tell you a heads up. On the final exam, you're like, what? You're talking about the final exam already? Yes. On the final exam, you're going to be able to use this method right here. So highlight it, put a little sticky note on it. But we're going to be able to solve this polynomial, and it looks horrible. X cubed minus 2x squared minus 5x plus 10 equal to 0. And again, you can go to your graph it and see the x-intercepts. But we want you to show your work. Obviously, we're not here just to punch numbers in a graphing utility. But this is the grouping method. So when did you learn the grouping method? It was back in Algebra 1 if you're fresh out of high school. Or you actually have seen it in Math, CCDM 114 and Math 120. But technically, here's the grouping method. You're going to have 4 terms. So 1, 2, 3, 4 terms. And you're going to have x cubed. So I'm going to write it again. Since I have all this space, I'm going to write it again. And so in essence, this is what you do. So taking it really slow here. You're going to group this one. And then you're going to group this one right here. So you're going to see what they have in common. So for this one, it's x cubed minus 2x squared. So they both have an x squared in common. So factor out what each group has in common. So this one's going to be an x squared. So x squared times what gives me an x cubed, it's going to be an x. And then x squared times what gives me minus 2x squared? It's going to be minus 2. Now, we can't forget to bring down this sign. So that's very important to me, and it should be to you. So we're going to bring it down. And then we're going to see, okay, so for the next one, should maybe make it this color. Oh, and I write a plus, bring it down and I write a plus. My goodness gracious. Sorry about this. So let me bring it down. Right. Just a minus. So now we want to know, and I'm going to do this. What do the 5x and the 10 have in common? Well, they have a 5 in common. So I'm going to take out a 5. And you need to realize this is going to be minus 5. So minus 5 times what gives me minus 5x? It's just going to be an x. Huh, and then I picked blue and I picked purple. There. And then minus 5 times what gives me a plus 10? It's going to be a minus 2. And then I still have it equal to 0. So here on this one, this is the key. If you grouped it right, this right here and this right here should be identical. If they're not right, then you did something wrong. And so the trick is that you're going to have a set of parentheses here. This is going to be x minus 2, which is what you have in the two parentheses together, because you're factoring it out. And then I'm going to put it in another color here. What color of all the colors that I have? This x squared and this minus 5, you're going to put it here. You're going to have it equal to 0. And again, technically, I don't like just saying the trick, but why? Why is it that this works? Because technically you're factoring out an x minus 2. So watch, if I have an x minus 2 and I factor it out and I set up another one, then I'm saying the following. X minus 2 times what do I put here gives me x minus 2 times x squared. Well, x squared. And then here I'm saying x minus 2 times what gives me an x minus 2 times a minus 5. Well, a minus 5. And you get the exact same thing that you did right here. And then you set each factor equal to 0. So here on this one, to 0, I should say. So it's going to be x minus 2 is equal to 0. And this one's going to be x squared minus 5 is equal to 0. And if I solve for x on this one by adding 2 to both sides, I get x is equal to 2. And then if I add 5 to both sides here, I get x squared is equal to 5. And so here I get x, to get rid of the squared, we can't forget, we take the square root. And this is going to be x is equal to positive and negative square root of 5. So how many answers so what are my answers? 2, and then technically positive square root of 5 and negative square root of 5. And I know some of you want to, so here's the clincher. For graphically, so I'm ending it on a sour note here. If you want exact answers, you got to, for this particular problem, you have to do it algebraically, because the square root of 5 is a decimal answer. It's an irrational number. But we can check it just to see that graphically we're getting about the same answer here. So let me graph it. It's very small. So this is going to be x to the power of 3 minus 2x squared minus 5x plus 10. And so here on this one, here we go. So I have to zoom in here because I have 3 answers. So here, this one there's my 2, 0. And then this one is negative 2.236. And this one is positive 2.236. And I leave it up to you, but the square root of 5 is about those numbers right there.